In the last section, we looked at solving linear inequalities. What about other kinds of inequalities? After all, after we solved linear equations, we went on to solve quadratic equations. What about quadratic inequalities? What about inequalities that have x squared in them? How would we solve those? For example, take the quadratic expression x squared minus 4x minus 45. And it might help you to visualize what's going on if you think about the graph of y equals x squared minus 4x minus 45, which looks like this. Okay, let's start out with an equation. We know how to solve those. For what values of x is x squared minus 4x minus 45 equal to 0? So we could solve that by factoring. Factor x squared minus 4x minus 45 into x minus 9 times x plus 5, and then set each factor equal to 0. So x minus 9 equals 0, or x plus 5 equals 0, and then x equals 9, or x equals negative 5. So those are the two solutions to that equation. Those are the two values of x that make x squared minus 4x minus 45 come out to be exactly equal to 0. And if you look at the graph, where do those show up on the graph? Well, those are the points on the graph where the y coordinate is equal to 0, where x squared minus 4x minus 45, if we're calling that y, we're looking for the points where y is 0, and those are the x-intercepts. So we've got one of them at 9, and one of them at negative 5. Now, for what values of x is x squared minus 4x minus 45 less than 0? Okay, so here what we're calling y, we're asking when is it less than 0? On the graph, the points where y is less than 0 would be points that are below the x-axis. The points down here are the ones that have negative y coordinates. And when does that happen? For what values of x? What happens when x is between negative 5 and 9? So that's the answer to question B. For what values of x is x squared minus 4x minus 45 less than 0? Answer, when x is between negative 5 and 9. Okay, then for what values of x is x squared minus 4x minus 45 greater than 0? Well, on the graph, now we're looking for the points where the y coordinate is greater than 0. And that would happen with points that are above the x-axis. And on this graph, the points that have positive y coordinates, because they're above the x-axis, the x coordinates are either over here less than negative 5, or they're over here greater than 9. So the answer here is x is less than negative 5, or x is greater than 9. A couple other questions we could ask. We could ask, for what values of x is x squared minus 4x minus 45 less than or equal to 0? So there we just have to put together the x's where it's less than 0, which are everything between negative 5 and 9, and the x's where it's equal to 0, which would include the negative 5 and the 9. So the answer there is when x is between or equal to negative 5 and 9. Negative 5 is less than or equal to x is less than or equal to 9. And when is x squared minus 4x minus 45 greater than or equal to 0? That's when x is less than or equal to negative 5, or greater than or equal to 9. Now that we've got some idea of what's going on, let's look at another example. Let's solve the inequality 2x squared minus 11x plus 5 is less than 0. I'm going to show you 3 ways you could solve this. 3 methods for solving a quadratic inequality like this one. Method number 1 involves looking at a graph, kind of like what we were just doing. So if you're doing it this way, you would look at the graph of y equals 2x squared minus 11x plus 5, which looks like this. And we want to know what are the x coordinates of the points where y is less than 0. Those would be the points below the x-axis. If we want 2x squared minus 11x plus 5 to be less than 0, and on the graph y is equal to 2x squared minus 11x plus 5, we're looking for points on the graph where y is less than 0. Do you see where that happens? It happens when x is between 1/2 and 5. So that would be the solution set to that inequality. The inequality is true whenever the number you put in for x is between 1/2 and 5. Greater than 1/2 but less than 5. Method 2. Here's how you could do it without looking at any graph or doing anything visual. Find all solutions to the equation 2x squared minus 11x plus 5 equals 0. That's the first step. So take 2x squared minus 11x plus 5 equal to 0 and solve that. I think we can solve that by factoring. That factors into 2x minus 1 times x minus 5 equals 0. So either 2x minus 1 equals 0 or x minus 5 equals 0. So in the one case, 2x would equal 1, so x would equal 1/2. In the other case, x would equal 5. So those two numbers are the two x's that make 2x squared minus 11x plus 5 come out equal to 0. So the next thing we do is we use those two numbers, those solutions to that equation, as dividing points to divide the real number line into intervals. If we divide the number line up at 1/2 and at 5, that divides it into 3 separate pieces. We got the part that's over here to the left of 1/2. We got the part here that's between 1/2 and 5. And we got the part over here that's greater than 5. And on each one of those pieces, as long as we stay within one of those pieces, there aren't any places where x is equal to 0. Where the whole thing, 2x squared minus 11x plus 5 is equal to 0, And it can't go from positive to negative or negative to positive without passing through 0. So on each one of these intervals, it's going to be either less than 0 that whole time, or it's going to be greater than 0 that whole time. So we don't have to check the whole interval, we just have to check any one point on the interval. And if it's positive at that point, it's positive for the whole interval. If it's negative at that point, it's negative for the whole interval. So we're ready for step 3 here. On each interval, check whether 2x squared minus 11x plus 5 is less than 0 or greater than 0 by picking any number from that interval and evaluating 2x squared minus 11x plus 5. So let's do that. Let's start by picking a number from the first interval. And we can pick any of these numbers that are less than 1/2, but an easy one to work with might be 0. 0 is an easy number to calculate with. Let's see what happens if we plug 0 in for x. We get 2 squared minus 11 times 0 plus 5, and that's just 5. Now remember, we were looking for when this comes out less than 0. 5 is not less than 0. So 2x squared minus 11x plus 5 is not going to be less than 0 on this interval here. We can rule this one out. What about the second interval, the one that's between 1/2 and 5? For that, we just have to pick any test value anywhere between 1/2 and 5. How about 1? 1's a nice easy number. When I plug 1 in for x, I get 2 times 1 squared minus 11 times 1 plus 5. Remember, squaring comes before multiplication. 1 squared is 1 and 2 times 1 is 2. Minus 11 would be -9, plus 5 would be -4. And that is less than 0. So on this interval, when we plug in a number between 1/2 and 5 for x, 2x squared minus 11x plus 5 does come out to be less than 0. What about this third interval? Pick a number anywhere over here greater than 5. How about 10? If I plug in 10, I'm doing 2 times 10 squared minus 11 times 10 plus 5. That would be 2 times 100, which would be 200, minus 110, so we're up to 90, plus 5 would be 95. Is that less than 0? No. So this is not part of the solution set. The only interval we got where 2x squared minus 11x plus 5 turned out less than 0 was in here from 1/2 to 5. So that is the solution set. And here's a third method you could use. Factor this quadratic polynomial. So in this case, it would factor into 2x minus 1 times x minus 5. So we're looking for when that is less than 0. And for that whole thing, something times something else, to be less than 0, one factor has to be negative and the other one has to be positive. If we had a positive times a positive, that would be greater than 0. If we had a negative times a negative, that would be positive, so that would be greater than 0. But if one of those is positive and the other one's negative, then when we multiply them together, we will get something that's less than 0. So let's see when that happens. When is 2x minus 1 positive? When is it greater than 0? Well, that would be when 2x is greater than 1, so x is greater than 1/2. So when x is greater than 1/2, the first factor is positive. When x is less than 1/2, that first factor is negative. Now what about the second factor, x minus 5? That would be positive, that is greater than 0, when x is greater than 5. And it would be negative when x is less than 5. Now look for the x's where one of those factors is positive, but the other one's negative. So we don't want them both to be negative. We don't want them both to be positive. We want one of them to be positive and one to be negative. And the place where that happens is where the x's are greater than 1/2, but less than 5. Okay, I'm going to end up with a few more really quick examples, but if you want to try figuring these out yourself, pause the video and see if you can come up with the answer before I tell you what it is. X squared minus 49 is greater than 0. The graph of x squared minus 49 looks like this. And the x's that make x squared minus 49 come out greater than 0 are when x is less than -7 or x is greater than +7. How about x squared plus 6x plus 10 greater than or equal to 0? The graph of x squared plus 6x plus 10 looks like this. If we're looking for where that's greater than or equal to 0, that would be points on the graph with a y-coordinate that is greater than or equal to 0. And actually, they all have y-coordinates greater than or equal to 0. So this is true for all real numbers. You can plug in any x at all, and x squared plus 6x plus 10 will always be greater than or equal to 0. And how about x plus 1 over x minus 5 greater than 0? The graph of y equals x plus 1 over x minus 5 looks like this. We're looking for where that's greater than 0, so look for the x's where you have a point above the x-axis, where you have a positive y-coordinate. That happens here where x is less than -1, and it also happens over here where x is greater than 5. So that's the solution set. X is less than -1 or x is greater than 5.